Well, hello everybody. I really like this quote by Glenford Myers. You see it? He says 95% of the words are spent extolling the benefits of modularity, and very little, if anything, is said about how to achieve it. And you know, everybody is talking about those microservices nowadays. How great they are, how to deploy them, how to orchestrate them, and of course, all the infrastructural stuff like Docker, Kubernetes, Kafka, serverless. But I think this much more fundamental stuff deserves way more attention than it receives. Modularity. How to decompose a system into microservices. Where do we draw boundaries between services? How to decide whether some functionality belongs to one microservice or another one? And overall, how to achieve good design and architecture. And by the way, it may sound like this guy, Glenford Myers, is someone from the microservices community, right? He's not. Actually, this quote was taken from this book right here. It is almost as old as our industry. It's 40 years old. In justice, I want to dedicate the next 50 minutes to this topic. How do we achieve architecture with microservices? All the usual suspects in conversations about microservices. You will see what exactly bounded context are. It's them from business domains, microservices, and we'll see the different ways that microservices interact with each other and how to optimize those interactions. But before we begin, I have to say that this talk is based on my experience the last 15 years of working with distributed systems. I want to cover a lot of stuff, and I might rush a bit. So if something is not clear, or if you have a question, please don't wait till the Q&A at the end. Instead, just ask it right away, okay? So this is our official agenda. We'll see 3 strategies to... We'll see how to apply these strategies in the microservices realm, and we'll go over some design heuristics for optimizing microservices-based architectures. And since I don't want to bore you to death with theory, I will use our company's business domain to illustrate all the technical concepts. With that, I will introduce you to our business and show you what we are doing. Say you're producing a product or a service. Our company allows you to outsource all your marketing-related chores. We'll come up with the best marketing strategy for your product. Our copywriters and graphic designers will produce tons of materials, such as banners and landing pages, that will be used to run advertising campaigns to promote your product. All the leads generated by these campaigns are going to be handled by our own sales agents who will make the calls and sell your products. And most importantly, this whole process provides many opportunities for optimization. And that's exactly what our analysis department is going to do. They're going to analyze all this data to make sure that you are getting the biggest bang for a buck, whether it's by pinpointing the most successful campaigns, most effective creatives, or by making sure that the agents are working on the most. That's the business domain of our company. And as I said, I'm going to use it for demonstrations of technical concepts. And speaking of technical concepts, let's see some ways to cut a system into services. I call them position strategies. The first one is bounded context. Very often this term, bounded context, is the same thing as microservice. So let's see what those bounded contexts are. The notion of bounded context comes from this book, Domain-Driven Design, Tackling Complexity in the Heart of Software. Please raise your hand in this book. Awesome. You're right. For the rest of you guys, I will do a brief introduction to domain-driven. Eric Evans claims that software projects fail because we, software engineers, do not understand well enough the business domains that we are writing software. This results in poor models of business expressed in code, logical code bases with the business and its needs. In other words, projects end up implementing the big ball of mud architecture. To improve the success rates of our projects, Eric suggests to start with fixing our communication with business domain. People who know each and every detail about business domain because it's their job. And for that, DDD proposes to use one language that both software people and domain experts understand, the language of the business domain. Of the technical jargon, we should use the terms of the business, understand their meanings, and use this language in all project-related communications, such as test scenarios, conversations, especially with domain experts, and most importantly, the code we write should also speak this language. This practice is called ubiquitous language. This language should be ubiquitous all across the project. Once you cultivate a rigorous ubiquitous language, it becomes the model of the business domain that we implement in code. Language is the model. And that's why I've said that the code should also speak the ubiquitous language. However, coming up with fast ubiquitous language can be tricky. As in any other spoken language, you may encounter terms that mean different things to our company. We have campaign managers and sales agents. And for lead means very different things. For a campaign manager, a lead is a notification that somebody has shown an interest in one of our products and has submitted his contact details. For sales agents, a lead is a much more complex entity. It has lots of data associated with it and has a very rich and complex behavior. The question is, how should we model this entity in code? Should we combine both worlds in one object? Or should we define two different objects and come up with some creative naming scheme like campaign lead and sales lead? Well, according to domain-driven design, we should do something else. In case of conflicting models, such as in the case, we should split the language into two separate languages and explicitly define the context in which each language can be applied. In domain-driven design lingo, this notion is called bounded. Again, in case of our company, we have leads in two bounded contexts, marketing and sales. Each bounded context defines one and only one model of the lead that is correct in its boundaries. And of course, these boundaries include other business entities and processes related to each context. And of course, these related entities can only work with one model of a lead, either in the context of marketing or in the context of sales. Ultimately, we can use these boundaries to decompose systems into services. Each bounded context becomes a separate service. Marketing service and sales service in our case. And that's our first strategy, decomposing into services based on bounded context. However, these services represent pretty wide areas. If we look deeper, we will see that each bounded context spans multiple business areas. For example, in marketing, we have creative catalog for organizing creatives, contracts for managing relations with publishers, campaign management for running the actual campaigns. And since there are no conflicting terms or models here between these areas, they all belong to the same bounded context, marketing. Same thing is in the sales context. Here we have CRM, desks, commissions, and other business areas. In domain-driven design terms, these business areas are called. Do not mistake them with the company's domain. The business domain of our company is customer acquisition, And to achieve it, we have to implement these subdomains. We domains to serve as the physical boundaries of services. In our company, we have lots of services adhering to this strategy. For example, campaign management, content catalog, and others. So the second strategy is using subdomains as boundaries for services. And this approach is actually quite common. But there is another one, striving to even smaller services. Inside of subdomains, we can find business entities and processes, the so-called business logic. Or in simplistic terms, these are the nouns and verbs. For example, in our campaign management subdomain, we have business entities such as campaign, funnel, target market, and others. And these entities can be used as boundaries for designing services. And this is the third decomposition strategy, having each service represent one business entity or process. We've tried this approach as well. It worked great in some cases, but it failed more than miserably in others. Anyway, this is definitely a viable approach, albeit can be dangerous. A bit later, we'll go over some heuristics for applying this strategy safely. So those are the three strategies that I wanted to show you. A system can be decomposed into bounded contexts, subdomains, and into entities. Decomposing further into specific methods and actions rarely makes any sense, so we'll stop here at bounded contexts, subdomains, and business entities. And you're probably thinking now something like, where are those damn services? And that's the question I want to ask. Who thinks that bounded contexts are microservices? No one. Subdomains. Okay, and business entities? Okay, so subdomain. Let's see. First, bounded context. We've seen that bounded context defines the applicability area of ubiquitous languages, or in other words, of models. I've shown you an example of conflicting models from our company, LEAD. Same term that means total and sales context. We split the system into two distinct models, each relevant only in its own bounded context. Which means, if we cross this boundary, we'll end up with inconsistent models or unexpected behaviors. And that implies an interesting observation. Bounded contexts are not the smallest. They are quite the opposite. Those are the boundaries of the largest monolith possible. And let me explain it in a bit more detail. Naturally, bounded contexts contain multiple related subdomains. You can move those subdomains around. You can compose them further into smaller bounded contexts. But as long as you don't the boundary of models, equally good and valid bounded context. Therefore, bounded contexts define boundaries of the biggest valid monolith possible. And the word valid is the key here. It's not a bad thing. Such monolith won't necessarily lead you to big balls of mud. It's a viable model that we can work with. But that idea doesn't quite fit the notion of microservices. So for microservices, we have to look elsewhere. And we are left with two options, subdomains and business entities. To see which one is the better candidate to play the role of a microservice, let's take a step back and define what are those services and is a unit of functionality exposed to the world. Or a bit more elegantly, according to the guys behind SOA, a service is a mechanism to enable access to one or more capabilities where the access is provided using a prescribed interface. This prescribed interface part is very important. Randy Schaub, one of the pioneers of the microservices movement, defines these prescribed interfaces as any mechanism for getting data in or out of the service. It can be synchronous, such as plain request-response model, or a bulk ETL operation to process a large volume of data. It can also be asynchronous operation by producing or consuming events. But overall, synchronous or asynchronous, those are just mechanisms for getting data in or out of the service. It's interface. Randy Schaub also calls the interface as the service's front door. I really like this analogy. And that takes us to the definition of a microservice. A microservice is a service with a micro interface, as simple as that. A micro front door. The reasoning behind this is straightforward. Less connection points between services reduces coupling between them, limits their reasons for change, makes it easier to understand each service in particular and the whole system in general. It provides better fault isolation. It makes services more autonomous for development, management, and scale. Also, we all know that microservices, no other service should be able to access a microservices database directly, but only through its public interface. Why is that? Well, because if a database is exposed outside, it becomes an enormous public interface. How many different SQL queries can you execute on a relational database? I guess infinity is a pretty safe estimate. But there is a caveat here. Even a micro public interface might sound pretty simple, right? Let's limit public interfaces to one method only. You cannot go farther than that. Those will be perfect microservices. Well, not really. Let's see what happens if we do just that. Say we have this backlog service with 8 public methods. And we want to apply this naive decomposition here. Each service will expose only one public method. But since those are well-behaved microservices, each of them will have its own database, and no other service is allowed to touch it. But they do have to work together somehow. They have to synchronize the changes the service is applying. And for that, they have to expose additional public interfaces for integration purposes only. When visualized, those integrations and data flows like this mess right here. So paraphrasing Randy Schaub's metaphor, we've definitely minimized the front door. But due to systems requirements, in addition to the front door, we created a huge staff-only entrance, the one which is used for integrations with other services. Therefore, the threshold on which a system can be decomposed is defined by the uses of the whole system. So neither subdomains nor business entities can be treated as microservices in all cases. It all depends on the system that you are building. And if we look at the bigger picture, we can see that microservices are not really about what happens inside of a service. Microservices are about interactions and couplings between the systems or components. To put it another way, what happens inside of a service is local complexity, and what happens between services is global complexity. And here I want to quote Glenford Myers again. He says, global complexity is the complexity of the overall structure of a program. For example, the degree of association or interdependence among the major pieces of a program. And again, I am describing this new hip architectural style by quoting a 40-year-old book. There is nothing surprising here. The ideas behind microservices are nothing. Those are age-old design principles. They were tested out in different paradigms, even in other industries. For example, that's what the inventor of the internet, says in his Principles of Design article. He says, when you design a system and the features can be broken into loosely bound groups of relatively closely bound features, then that division is good design. This is just good engineering. Maximizing connections inside of a service, increasing cohesion, and minimizing connection outside of it, reducing coupling. This is just good engineering. In the same post, he addresses the fact that components make up systems, and those systems are components themselves in other larger systems. And we always have to keep this in mind when designing software. Also, in 1972, Barbara Liskov published a paper called A Design Methodology for Reliable Software Systems, in which she discusses how to achieve good modularity. She likens good modularity to minimizing connections between modules. So I want to reiterate, a microservice is a service with a micro interface, micro front door. The correct size of the interface is not an absolute value, it's relative. It's defined by the system that the microservice is a part of. And this brings us to good news, bad news. Bad news, there is no easy way to evaluate a system's design. In a perfect world, we'd be able to feed a diagram into some program and receive an objective grade, but we are not there yet. Good news, we've accumulated lots of design heuristics that can greatly help us to streamline the process of decomposing systems into microservices. I want to show you 10 heuristics that I found most useful at our company. First, always decompose to bounded context. Notice terms mean things to different people, define strict bounded contexts, and decompose the system accordingly. Do not implement conflicting models in the same service. Otherwise, there will be balls of mud. Second, do not decompose bounded context further unless you've got a good reason to do so. And this is my first law of distributed object design. Do not distribute your objects. You see, microservices are great. We can hear left and right about the benefits of this approach. But as each distributed system, they come with a set of hurdles. So before you decompose further, make sure you really need those benefits. If you are one team working on a greenfield project, maybe you can start with a simpler design and decompose it into microservices later when you really need it. Let's say you've evaluated the options and came to the conclusion that you do want those benefits to decompose further. The next level is the level of subdomains. And here I have to dwell a bit more on domain-driven design again. Domain-driven design distinguishes three types of subdomains: core, supporting, and generic. Actually, they are quite different. So let's see what they are. Generic subdomains are all the stuff that all companies are doing in the same way. For example, in our company, we have an access subdomain. Because we have to manage our users, we must ensure that they are only allowed to execute operations according to their roles. So we are using the OS2 protocol and an open source implementation of it. Our sales agents need a telephony system to conveniently make calls. So we created a Asterisk server to provide this functionality. And in marketing, we have to make sure we manage our finances correctly and according to the industry's regulations. That's why we have billing subdomain. All those subdomains are complex and boring. Since all companies are implementing this way, there is no point in investing in your own solution. Those are already just an existing implementation and use it, be it an off-the-shelf product or an open source project. It will be cheaper and less risky. Subdomains. Treat the third-party solution as a separate service, and of course, keep it in the boundaries of its subdomain. In addition, it may be very beneficial to abstract its model and implementation details by implementing a thin integration service that will be used as a proxy between the consumer and the adopted solution. The opposite of generic are core subdomains. Company is inventing something new or optimizes some existing practices to gain competitive advantage. In other words, the company is making money. For example, campaign management is our core business. We have our own way of managing and optimizing campaigns. Our CRM is also built differently from other CRMs on the market because it allows us to optimize a lot of processes and eventually minimize our spendings and yet to maximize our profits. And finally, we have a tailor-made strategy for calculating sales and commissions. It's pretty complex, because a lot of time and effort to find the perfect formula, but numbers show it was worth it. It works best for us and our sales agents. Inherently, the core subdomains have complex business logic, but contrary to generic subdomains, here we cannot and we do not want to use an existing to implement and invent our own solution. Since companies want to optimize their core business, they will try to find models and implementations that maximize their profits. Therefore, you have to implement this logic yourself. It is going to change, and it's going to change often, especially in the early stages of the project. Therefore, stay in the boundaries of the subdomain and do not rush to decompose them further. If you do have good reasons to decompose further, for example, because of scalability or security concerns, wait till you gain more domain knowledge. Do not decompose them right away. The last thing you want is to find yourself making changes across bad boundaries. In such case, the complexity of each change to the code base will be orders of magnitude more higher. And the last type is supporting subdomains. As generic supporting subdomains, they do not provide competitive advantage for the company, but they are needed to support the company's core business. For example, to publish advertising campaigns, we have to manage our creatives. We have to manage our contract with publishers. To have a CRM system, we have to manage our sales desks around the globe. There is nothing complex in these subdomains. We don't have to invent anything novel and smart here. Those simple CRUD interfaces for managing records. Also, contrary to the core subdomains, this business logic changes pretty rarely. Therefore, if needed, it is safe to decompose the supporting subdomains further, even at the earlier stages of the project. Okay, quick summary of subdomains and their heuristics. Generic, the complex stuff that all companies are doing in the same way. You adopt existing implementations and stay in the subdomain's boundaries. Core, the way the company is making money. Complex business logic changes often. Preferably stay in the boundaries of the subdomain, at least at the early stages of the project. Goes further only if there are good reasons for doing so. Actually gained enough domain knowledge. And simple subdomains that support the company's goals, the company's core business. And here it is pretty much safe to decompose further even into the level of business entities, and even at the earlier stages of the project. Now let's look at decomposition from a different angle. Let's say we have two methods that operate on the same data. We can decide whether they belong to one service. They can be decomposed into two services by evaluating their consistency requirements. If they require consistency control, which means only one of these methods can be executed in parallel, then both belong to one service. They cannot be decomposed. If one service should always read the last write of the second one, then they can be decomposed into two services, but integrated through a synchronous call. Lastly, if they can settle for eventual consistency, then they can be decomposed and integrated asynchronously. Of course, those are not hard rules. Those are just heuristics for what is possible. There is no point in implementing asynchronous communication if a simple synchronous call will do the job. And speaking of asynchronous communication, exchanging events became the default way of integrating microservices. Those events, just like methods, are parts of services' public interface. So let's see some heuristics for optimizing events. Often services can meet quite a few. This is especially true in event-sourced services. But do you really need to expose dozens or even hundreds of event types? In many cases, the events can be categorized into private events, which are the implementation details of the service, and public events, which are intended for public interface. Thus, exposing only public events minimizes the service's front door. To minimize event-based public interfaces is to compress them. Let's say you have a service emitting three types of events: email changed, phone number changed, and address changed. Do you really need to expose such fine-grained events to your clients? Think about combining them into one contact details changed event. And of course, if you need to, those smaller events as private implementation details, the broader event as a part of the service's public interface. And if you're exposing events at the service's public interface, make sure that they are explicit. For example, here's a service emitting the agent assigned to lead event. The meaning of this event is implicit. What does it mean if we receive three such events, one after another? Does it mean that three agents are assigned, or should the last event override the previous ones? This design can be improved, for example, by introducing an intermediate event stating that previous agent was unassigned, or have one event type but call it assigned agent changed. Both are much more clear, and the clients won't need to make any assumptions and guesses about its meanings. And the last two heuristics are for after the fact scenario. Let's say you have two services and you sense a design smell. Each time one of them changes, the second service has to change as well. Typically, that indicates that the services are tightly coupled. Therefore, evaluate those reasons for change, and if you check whether you can loosen the coupling. If not, consider merging them into a single service just to get. And for the final heuristic, let's get back to the public door metaphor. If a service's public interface is wide and contains many business-wise unrelated methods, then it can be split apart into smaller services. Also, compare the methods that are used for implementing business requirements, methods implemented for integration purposes. If more methods were added for the sake of integration, then consider re-evaluating the service's boundaries. The system's design might be simplified by merging some of those tiny services together. Okay, those were the 10 design heuristics that I wanted to share. Let's have a quick. First, a service is a unit of functionality exposed to the world of its public interface, its public door. A microservice is a service with a microinterface. The size of this microinterface is not absolute. It depends on the use cases of the overarching system. We've seen that minimal contexts do not implement conflicting models in the same code base. Always decompose to bounded context. Fowler's first law of distributed systems: you should think twice before decomposing further. Distributed systems have their challenges and hurdles. If you've decided to decompose further, evaluate the type of the business subdomain that you are working with. Generic subdomains, these solved problems, should be bought or adopted. The implementation can reside in a separate service and optionally be proxied by a thin integration service. Core subdomains are the competitive advantage of the company. They are complex, risky, and change often. Do not rush, decompose them into tiny services. Instead, stay in the boundaries of the subdomain and decompose further only after you've gained enough domain knowledge of the business. On the other hand, are simple and change much less often. Thus, they can be decomposed further even at the early stages. Evaluating consistency requirements can help us decide if two methods belong to the same service or we can split them across multiple services and how they should interact with each other. Exposing tons of different event types couples the services to their clients. Consider having private events as implementation details, but expose a more restrained set of public events. A way of minimizing the number of out-facing events is to compress data from multiple private events into wider public events. Make sure that events are self-describing and explicit. Do not make the clients second-guess their meanings, because otherwise it's just a different way of coupling. If you have multiple services in the same rate, look for ways to reduce coupling between. If it can be reduced, consider merging them into one service. And finally, evaluate the services' front doors, their public interfaces. If they are too wide, consider decomposing them into smaller services, or if there are much more integration-related methods, then consider reassessing the decomposition boundaries to simplify the system. This is the source code of this presentation. Everything I've shown you was composed from these books, papers, and presentations, and of course my personal experience. Any questions?
Any questions?
1, 2, 3, 4, 5. No questions. Thank you.
Thank you very much.